Hey there, welcome to the video where we're going to use some of the angle relationships that you learned about in the last class to actually justify missing angle measures in certain images that we see below here. So for the first three right here, 1, 2, and 3, you'll notice that they're all a missing angle within a triangle. And I want to remind you guys that triangles add up to 180 degrees. Now, a lot of you knew that, but real quick, just to prove it, I've got just a visual image here. I've got a rectangle, or better known as a square. And the square here, if I move this triangle into it, I just want to kind of show you that I'm cutting the square in half really. So if the square has a 90, 90, 90, and 90, it has 4 90-degree angles. So the square here is going to add up to 360. Okay. Now the triangle, see how it is half of that? This triangle is half. So that means that the angle measures this right angle plus this little guy and this little guy are going to be 180. And then this triangle over here would also add up to 180. And then all together, that would be a 360. So any triangle, it doesn't matter what the triangle looks like. It could be a right triangle. It could be an acute triangle. It could be an obtuse triangle. All of the three angles, when you take a triangle, if you add them up, it should be a 180 degrees, okay? So that being said, I'm just going to get my calculator real quick, just to make this part super easy. So if these three angles are supposed to add up to 180, I'm basically just going to take the 180 and subtract 75, and then I'm going to subtract the 72-degree angle, and that means that one has to be 33 degrees right here. So this is 33 degrees. And I can justify that because I can say triangles add up to 180, so I know I'm good to go. Now in the second image here, we have a 44-degree acute angle. We know the right angle is 90, so already we have the 90 and the 44. So total, that's 134. Now remember, we're trying to get up to 180, so I'm going to do 180 minus the 134, and that's going to be a 46. So that's a 46-degree angle right here. All right, and for the last one, we've got two acute angles already given, and then there's an obtuse angle right here that we're going to try to find. So we know we're expecting this to be more than 90 because it is a fat obtuse angle. So you see, I did both methods. I did the 180 minus this, or I added these two up and then subtracted from 180. I think it's easier to just start with the 180 in the calculator and then subtract the 41 that we see here. And then we're going to subtract the 27 that we see. So this has to be 112 degrees, 112 degrees. All right. Now, the whole point of today's notes are to be able to justify a missing angle using definitions of angle relationships. And by definition of a triangle, the angles add up to 180. So this right here that I'm highlighting in green, this is me justifying these answers that we just found in 1, 2, and 3. Okay. Now for number 4, I see here that I have a pair of vertical angles. You might remember from the previous video that these are vertical because they make kind of like the bow tie. Think bow tie. And here's kind of the weird, it's like a bow tie if you kind of look at it like that. So anyways, these should be equal. So if this is 135, then this has also got to be 135 degrees. And again, the things that justifies this is that these are vertical angles. We have vertical angles here. Now, in a little bit, you guys are going to be filling out a Google form where you have to tell me what relationship between the angles actually justifies the number. So here again, it's a vertical relationship. Anytime you have vertical angles, they are congruent. So that's how I can prove that that's a 135. All right, now over here in this next picture, I've got a straight line and a ray is coming out of it here to form this 125-degree angle. I notice that this 125 degrees plus x right there forms a straight line. So this should add up to 180. These are supplementary angles. So we're just going to do the 180 minus the 125 we already have. And that's going to be 55 degrees. So this angle right here has to be 55 degrees. And the way I can justify it or prove it is, again, that I've got supplementary angles here. Oops, that's not spelled right. There we go. Side note, these are also adjacent angles. They are adjacent, and that's just a definition that I can put there. That doesn't necessarily justify anything. The thing that justifies it being 55 degrees is really the fact that they're supplementary. So supplementary is what we care about here. Now to make the right angle, that's when we have complementary angles. So that's how we justify it, the definition of complementary. By definition, complementary angles add up to 90. So I'm going to take 90 and subtract the 43 angle that I have, and that means this should be a 47 degree angle, 47. So all we're doing is using our knowledge of these new vocabulary words to prove what these missing angle measures have to be. All right, so for this one, we've got some supplementary angles. And so if I do 180 minus the 29, I get 151. And again, that's because they were supplementary. Here, nice little bow tie, I've got the vertical angles. Those are vertical angles, so that has to be a 33 degree angle. And right here, X and 72 form this straight line right here. So it looks like we have supplementary. This is supplementary. And that's going to be, to get up to 180, that's going to be a 108 right here. 108 plus 72 gives you the 180. Okay, so this has to be a 108 degree angle. And again, that's because they were supplementary. So I didn't write those words down, but you will need that for your Google form. These were supplementary, these were vertical, and these were also supplementary. All right, now for this one in the Google form, it might ask you to list angle P, T, Q, or it might ask for angle R, T, S. I wanted to review with you guys how to format that. If you see P, T, Q, if you see angle P and then a T and then a Q, that's how you read that, angle P to T to Q. The 49 degree angle right here is angle QTR. And so if you put a QTR like that, it's the same as if I had put angle RTQ. Because R down to T over to Q, that's the same 49 degree angle, okay? So I've got a 49 degree angle here. And we see right here that this is a 90 degree right angle. So RTS is 90 degrees. RTS is 90 degrees. We've got a right angle there. Now, if this is also supposed to be a right angle, it looks like these are complementary. They should add up to 90. So PTQ is complementary to QTR. These are complementary. And so for this, if we want it to add up to 90, I'm going to put a 41 here. Be careful not to put a 51, because the 40 and the 40 gives me the 80, and then the 9 and the 1 is 10. So that's 90 total. Now over here, the given angle measure is angle QZY. It is an acute angle. So let's use that to find all these other missing angles here, okay? Now, first thing I can justify is a vertical angle. Vertical angles are always congruent. So this right here has to be 38 degrees. That's a 38 degree angle, okay? Now, if that's 38, I can use that to say, okay, well, this 38 degree angle is complementary to this and forms a right angle. So what plus 38 gives you 90? And that's going to be a 52 degree angle. This is 52 degrees. You might be thinking 62, but remember again, if you have 50 and 30, that's 80 plus now here, the 10 would give you 90. So just be really careful there when you're making a 90 degree angle. And here, this line in purple is a straight line. So we've already got 38 degrees. And so then this angle right here is supplementary to that to make 180. So we're going to do 180 minus 38 for this one, 180 minus 38. And so that's going to be a 112. That's not true. That's a lie. I don't know why I'm having a brain fart with this one. 180 minus 38. Oh, I know what it is. 180 minus 38, sorry. 142. I don't know why I put 112. A little brain fart, my bad. 142. Now I want to point out that, let me highlight it here, and let me use this blue highlighter, that this line right here, V to Z to Y, that's also a straight line that should be 180. And so my 38 here plus the 142 here, that's also forming 180. So that's just another way I could prove it. I could say, well, those are supplementary, so this has to be 142 because that was 38. So the way I started this one, I went from 38, I went vertical. Then I said because of complementary, I've got a 52-degree angle. And then I also said because of supplementary, no matter which way I look at it, this has to be 142. Now you guys are actually going to turn over, and here's a puzzle sheet. You're going to fill out this puzzle sheet. Each one of these, you have to pick which one of the two answers you think it is. Let's do the first one together here. Two lines that intersect at right angles. If they intersect and make right angles, y'all know that that's perpendicular. Parallel, they would never intersect. All right, so for number one, it's letter N. So I'm going to come down here, find number one, and fill it in with a letter N. Okay. Now there's a word on here that I don't think we've discussed yet, and it's in number 3. A line that intersects two or more lines at different points is called A. A line that intersects two or more lines at different points. So do you see up here in this picture? I'm just going to label this line T. What I'm saying is that this purple line, it intersects at here there was a point and here was another point. Those are the two different points. So this is called a transversal. Okay. It intersects two or more lines. So number 3 is E. And there's actually another one here. We'll use anywhere you see the number, fill it in, and I think that takes care of them. A bisector, just so you guys know what a bisector is it cuts something equally in half into equal two parts. So if I had a line segment right here, and I put this red line right here, that is a bisector. If this length right here, if this was a length of 5, that means I can also say that this is a length of 5. So that's a line bisector. I could also have, whoops, that's a really bad line. Let me make a 90-degree angle right here. So if I have a 90-degree angle and I cut it into two equal lines, if this is 45 degrees, then this is 45 degrees. So let me highlight it in blue. This blue thingy is called an angle bisector. It took the right angle and bisected it. When you bisect something, you put it into two equal measurements by just putting a line in it. So that's what a bisector is, and I just wanted to explain that. Now for the rest of these questions, you're using this picture up here. I'll do one more with you. I'm going to do number 7 with, no, not number 7, sorry. Number 10. I'm going to do number 10 with you real quick. So it says in number 10, if the measure of angle 1 is 125, then the measure of angle 5 is. So in my picture up here, we were told that the measure of angle 1 was 125. So if that's a 125, it wants to know what was the measure of angle 5. Well, angle 5 was right here. Those are corresponding angles, and corresponding angles always have the same measurement. They're congruent. So if 1 is 125, then 5 also has to be 125. All right, so I'm going to come down here to that one. I'm going to pick this. So number 10 was letter H. So we've got an H here. Any other ones? Yep, there's one. So you're going to do page 6, and then you're going to just show me. I can check it off for you. There is no form for this. There is no form for page 6. However, when you get over to page 7, okay, there is a Google form for this. What you guys are going to be doing here is using these two given angle measures that I have highlighted in yellow. You're going to be able to tell me every single other angle that's here. Now, the way you can justify it, again, you've got alternate interior or alternate exterior angles. Don't forget about those. For example, if this 74-degree angle is in green, it is on the outside and therefore is an alternating exterior angle with this green angle here. Those are alternating and they're on the outside of my two parallel lines. Okay. So you are going to also complete this diagram. You've got a parallel line here and here. You've got a transversal that cuts across like that. And again, there's my alternate. Oh, let me highlight this one. There's another transversal. So here's alternate exterior angles there, 74 and 18. Those are alternate exterior. So if this is 74, you know this has to be 74 because of alternate exterior. That's one way to prove it. Now there's a bazillion different ways to prove all of these and to justify them. There's lots of different ways to prove it. But I wanted you guys to just see a list right here. These are all of the possible options. Don't forget, you could even say 13 and 15 and 11, these angles have to add up to 180. So you could even use that to find a missing angle measure. But what you're going to do when you get done with that, when you find all the missing angles, is down here, you're going to tell me the relationship between each of the angles. So the one that I just talked about up here, the relationship between this angle and this, I would say alternate exterior angle. Okay. If I said, what's the relationship between 8 and 10? You would tell me vertical. Those are vertical angles. So there is a Google form for this. There is a Google form for page 7, but there will not be a Google form for this. And that concludes the video now for how to justify the missing angle using your angle relationships. Thank you for watching.